completed nearly 38 years, and the college is offering 9 undergraduate programs and 4 postgraduate programs, and also college is offering full-time PhD program, and we have an excellent placement programs, and nearly 90% of the eligible students will be placed in various multinational companies, and at an average 85% of the student will pass in distinction and first class. They have a good and large alumni situated in various places in the global, and they are helping us in building this college for various activities.
ഇല്ലാതെ പറ്റത്.
Good evening, everyone. Am I audible?
Yes, Pranav, you are audible, visible.
Awesome.
So we will start by exactly 7 p.m.
Sure.
I already streamed live session.
Okay.
Session will be from 7 to 7:50, and last 10 minutes will be for queries. So the participants are going to ask query in the YouTube live chat box. So our coordinator will be monitoring continuously. So they will note it down the important questions reasonable. So we will read out can answer. Thank you.
Works,
And
works.
thank you very much for your effort and time, spending time with us.
No, thank you for giving me the opportunity. It sure is fun to kind of address our students and definitely impart what we know.
Previously, last 2 days we have conducted. It's actually started from Monday.
Right, right, right. I've seen the schedule you have sent me, yes.
Yes, yes.
I did attend.
So we'll wait for 3 minutes more. Myself, Dr. Abid Naimuddin, Associate Professor of Electrical and Electronics Engineering Department and convener of this FDP, Honorable Chairman of G. Pullareddy Engineering College, Autonomous, Kurnool, Andhra Pradesh, India, Sri P. Subbareddy Garu, respected Principal Dr. B. Srinivas Reddy Garu, Head of the Department Dr. K. Sri Gauri Madam, Head of the ECS Department Dr. R. Praveen Sam Garu, Head of the EC Department Dr. S. Nagaraj Rao Garu, eminent faculty members, dear participants, good evening to all of you. It gives me a great pleasure to welcome all the participants to the day 3 of this 1 week international level faculty development program on introduction to artificial intelligence during 9th to 14th October 2023, organized by Department of Electrical and Electronics Engineering in association with the NI LabVIEW Academy of GPREC, Department of Emerging Technologies in Computer Science and Department of ECE. And I'm very happy to share that we got tremendous response from the participants. A total number of 1,872 participants has been registered for this particular workshop. And I am happy to share that our college management is very supportive to conduct such type of workshops. The participants are from across the globe internationally. Few of the participants registered from Dubai, Kingdom of Saudi Arabia, United States of America, and Australia. And from India, the participants are from Kashmir to Kanyakumari, covering almost 23 states. Hence, I thank all the participants and stay online in the YouTube live. If you are having any queries, please ask the questions in the chat box. Our coordinator will keep an eye on the on your questions. Your questions will be definitely answered in the last 10 minutes of the session, that is from 7:50 to 8 o'clock. And the feedback link will be posted in the live chat box of YouTube, which will be considered for attendance of today's session. So all the participants are requested to submit the feedback, which will be available in the live chat box only at the end of this session. Thank you very much. Now I request Tanvi Reddy to introduce today's speaker.
Good evening to one and all. I, P. Tanvi Reddy of 4th Triple E, take it a privilege to introduce today's speaker, Mr. Pranav Bhargava. Mr. Pranav Bhargava is current working as Data Science Manager at SquadStack. He has 7 years of experience in the industry. He is accomplished with executing and managing not just data science projects, but also leading data science product initiatives. He is an expert at building pieces from the ground up. As an integral member of the SquadStack team, he has undergone an impressive growth journey over the last 7 years. Starting as a data analyst, he has steadily progressed to his current role, managing a team of data scientists, all while actively contributing to the development of several products within the company. Our speaker's dedication has not only enriched his own career, but has also positively impacted countless individuals and communities. His commitment to excellence and his ability to communicate complex ideas in an engaging and accessible manner make him an ideal choice to lead us through today's session. On behalf of G Polarity Engineering College, I would like to thank today's speaker, Mr. Pranav Bhargava, for dedicating his valuable time with us. Thank you, everyone. Now I request Dr. Abid Naimuddin, convener of the FDP, to take over the session.
Thank you, Tanvi Reddy. Thank you. Now I request the speaker of today's session, Mr. Pranav Bhargav, to take over the session.
Sure.
So let me
Thank you.
end this screen. So now you can share your screen, sir.
Got it.
Please share
Thank you
entire
for,
window so
yeah.
that yeah, it is visible.
Okay. Thank you for the warm words, and thank you for the opportunity in kind of being able to share what I have learned over the years with students here. So
Thank
thank
you.
you for that opportunity.
Thank you. Thank you.
So good evening, everyone present. I am here from Squad Stack. I'm a decision science manager currently here. I've been here for 7 years, and my journey started in the field of data science during my engineering, similar to you folks, back in the year 2015, which was, I think, the third year of my college. And at that time, I think data science had, let's say, just started out or started coming to India in terms of what it meant, and people understood what it meant at that point of time. Right now, it's, let's say, given that data science itself has the term science in it, which simply means that it's like science. Usually, there are things like hypothesis, bets, and experiments that we want to take forward together, and basis that understand the impact it can create in, let's say, a process or on business specifically. That said, like every science experiment, there is a process to guide us through that may not fit all projects at all times, but definitely can be used as a guiding principle. So, here I am today to present a short talk on estimating and managing a data science project. And before we begin, I think it's very important to understand why does a project need to be estimated or managed. So, let's say if projects were not managed at all, specifically data science one, in any team, if you're working, different people will come up with their own ways of understanding, managing, or following certain practices. That can lead to a lot of rework happening, along with not easy for context transfer to happen. So let's say if I am working on something and somebody else is working on something in a different way, and someday we need to switch, or I need to gain context of what the other person has done, it's very tough. That is why it's easier for a team to follow common practice. Another reason is usually the data science projects that are sponsored or let's say suggested by somebody also need clear visibility on what is happening at one time, what will come out as a result, what do we expect as a final output that will create business impact. So, the second aim mostly is to give stakeholders visibility so that they understand when to expect an output or when to move forward. The third part of this is specifically that right now, let's say if a goal comes to us, a simple goal as predict the sentiment of COVID related tweets via Twitter, it is very tough. It is as a goal, it's very good to understand. Now, as an executioner or let's say an individual contributor, you need to be able to break down not just the goal, but what task will you do, when, and how much time should you end up spending on each of them. Right now, given that this is science, it is very easy to get lost in one part. So let's say how much data needs to be collected is also a part or a task that we need to address. I can get infinite amount of data, but that means that it will take infinite number of days to fetch that data. So whatever data I need, let's say 5,000, 10,000 tweets to start, maybe they can be fetched in 3 days. So that allows us to limit what we want to do while also being able to create some impact. Now that we have understood the why a project needs to be managed or estimated, let's move forward to look at the process. This process is a specific in-depth process that we have and use at Squad Stack specifically. Later, what we'll do is we'll try to fit this into a very standard and the most popular framework that is being used for data science projects today that was established back in 1999. So we look at use cases, we look at examples, and then bring it all together. So at the start of the process, there are roughly 9 to 10 phases of the entire process. We start with something as simple as requirement gathering or closure. This can come from stakeholders or leaders or managers or even from oneself if the project is your own project or your pet project or something that you're doing to learn more, right? So the requirements could also come from there. The aim of this phase is to understand specifically the situation and the problem itself, along with the possible impact it can bring if solved to a certain extent. Now, what I mean by this is, let's say somebody comes and tells us that you need to work on figuring out COVID, let's say COVID tweet sentiment. Then, why are we doing it? What kind of impact will it create? What kind of data do I fetch from? Let's say, is there any specific region I should focus on? All these are part of the requirement gathering or closure process. This helps you understand what the other person says when they bring a project to you or what they want in return. So it's very critical in that way. Now, coming to the next piece, which is literature survey. Literature survey in itself, if you take it from a research perspective, a research study usually requires extensive exploration. And at times, one is required to read more than 100 papers to actually build a good research paper, or let's say build an understanding of what they are going to delve into. Here, we are talking about practical projects that need to be implemented in business in a, in a quick turnaround time. When I say quick turnaround time, you would mostly understand that people want a proof of concept that whether this works or not. So, as a requirement, you just take, let's say, a couple of days to understand what is the best solution out there, and can that be used or can that be followed as a guiding light for your own problem solving process. That said, this is also very useful when essentially you do not have a baseline and it helps you to decide the goal. So, for example, if a product stakeholder comes back to you, and by stakeholder I mean a product manager in this case, if a product manager who's given you the problem comes back to you and says that I need 99% accuracy on this problem when it is solved, then you can come back and say that look, the state of the art for something like emotion understanding on from audio calls is just 75% out there. If it's 75% out there, then I can at max by custom tuning the model, or let's say taking an approach, take it max to 80. But I cannot beat it by a lot because it's already state of the art. So you understand that 99% is not possible today in today's world. It may be possible if you keep adding more custom data specific to your case, use case, to the model over time, and then it keeps improving. Coming to the next phase here, once you have understood, once you have gone through the literature survey, you now have an understanding of what kind of data is used or needed to actually solve such a problem. Once you understand that, you'll have to check all the sources and get significant sample of data ready for the same. So let's say if I was to think about that COVID tweet sentiment problem, fetching data from Twitter itself is needed, right? Now, can I distinguish it via geographical factors? Can I distinguish it via time? Can I get the results on distinct users? All of those things. Those are again questions of data availability. Now, for each person that I get, can I also get from somewhere personal information about their demographics? Can I get which region are they in? Can I get what age they are at? Can I get what city they are in? Or let's say what education they have had. All of these things can be fetched from a separate source if you have a unique identifier. That unique identifier could be the name, email, phone number, address, anything, right? So all your various sources need to be collated and you need to understand what data is available. In the next step, when you move to data exploration, now this is one of the phases which takes a lot of time and you need to spend time here. This is the part where data needs to be understood in a very clear way. Each column needs to be assessed as to what it means, how often that data gets generated, how often that data gets updated. You need to also start looking at whether the data is skewed or not, whether the data has normal distribution, whether certain metrics, let's say certain data could be categorical in nature, ordinal, nominal, all of these being different classes of data, while some could be numerical. So let's say something like sales data is numerical in nature, while age bucket, when I say age bucket, it could be 18 to 25, 25 to 30, or it could be just numeric age as well. So in this case, let's say an age related column needs to be checked for its 5 point summary. 5 point summary translates to knowing the minimum value, 25th percentile, the 50th percentile, the 75th percentile, and the maximum data. So this allows you to understand how the spread of the data is. The second piece here is to understand how many empty values come out. If let's say for a variable like age, 90% of the values are empty, it's definitely not usable. and that kind of hinders you from using that column or using it as a feature in future. The second thing to notice is whether this is the age of the person or whether it's the age of that person on a platform. So let's say how long has it been since Pranav joined Squad Stack? The age comes out to be 7 years, while my actual age is 29 years. So there's ample difference in understanding those variables. You should have a very in-depth understanding of what data exploration means and how you can move forward with it. This is one of those pieces where you can get lost because what you can do with data is has no limit. You can keep on running analysis, you can keep on checking, exploring, you can add visuals here, you can do whatever you want. But there has to be a limit here as to the time you spend. We'll look at a specific case study to understand how you can limit time and what possible time can be for a use case. Let's move on to data transformation. Now, this part is another crucial part where we spend time in transforming data into the way we want it to be understood by the model. For example, if you are using age and it's numerical, maybe if it's age of how long has Pranav been in Squad Stack, we may want to bucket it in less than 6 months, 6 months to 1 year, 1 year to 3 years, 3 years to 5 years, and greater than 5 years. So that allows you to divide it into categories that are more meaningful. That helps you understand patterns of people in a bucket rather than in an individual way. So that is how you can keep on transforming your data in one way. The other is you add more features. So let's say if I'm looking at textual data, the features could be adding count of the number of frequency of the number of times the word occurs. While if I'm looking at audio features, I can kind of derive things like tonality change, pitch, speech of rate, number of interruptions, number of pauses, all of those things. Those are all feature engineering that we derive from the data that we use. So this is the step where the feature engineering happens, and it's one of the most critical things. It's very important to kind of focus here specifically because if you don't focus a lot, you won't be able to teach the model or the algorithm what you wanted it to learn. Moving forward to one of the most exciting phases, and I think this is what everybody looks forward to as well when they're working on a data science project. But this is where people end up spending only 10 to 15% of the overall time is generating the first model or the algorithm. Now, this process is where you start, let's say if it's a classification problem, you start dividing the data into train and test sets. Train and test sets are simply, let's say, a division of the entire data where 80% of the data could be put for train, while 20 for testing, and it can vary according to your own use case. Now, 80% of the data that is pushed for training has labels already. Let's say if I'm doing a COVID tweet sentiment classification, then I'll have labels like whether the tweet was positive, negative, neutral. If I have a five classification method for emotions, then I can also have happy, sad, angry, neutral, uh, and let's say some other emotion which comes to mind. Yeah. So that is how you can actually divide the entire data set into train and test, and you train your first model or an algorithm in case it's unsupervised in nature. So that is how you start with the first model. Once you have your first model, you have a baseline set here. Now, that baseline itself is the point from where we would want to make the model results better. And that is where iterations come into play. Do note that iterations mean you could do anything with the entire project. So let's say if you start questioning the data itself, you can go back to data availability, explore data again, and come back via the same process. So you could move from iterations back to data availability. If you're questioning the approach that you took, you can even go back to literature survey. If the requirement itself has changed, you can go back to requirement gathering. Now, the aim of this is to usually better the results that we have got from the first model or algorithm. So let's say you got 70% accuracy from the first model. Now your aim should be to at least increase this by 10%, which is 80%, and 10 absolute, not 10% of 70. So in absolute terms, you want to make it to at least 80, and you could do it via changing, let's say, hyper-tuning the parameters of the model itself, the features specifically, changing the features, or something else. So you could keep doing those processes, and again, this has to be time bound so that you don't keep iterating and there's no business impact coming out of it. That is a key indicator and very important to keep in mind when you go through the iterations. Post you have some iterations, you can come back with a final result, which means that you can essentially have a, let's say, a report, a summary, a presentation, or you could have a single score as well, or you could simply have the entire documentation on what was automated completely. This is the part where you actually do the deployment as well. Now, in the estimation process, usually deployment is done by machine learning engineers while the work is done by a data scientist. So, what we are doing right now is we are trying to estimate the project from a data scientist perspective and not from a machine learning engineer perspective. So, do keep in mind that deployment time might be separate in some cases, depending on the maturity of the organization where you're working. Post, you have got the final result. Now, this is where you share the impact with stakeholders. From a data science perspective, you may want to share values, evaluation metrics like precision, recall, coverage. From a business perspective, you will want to share the time saved, the cost saved. So let's say time is usually saved when you're looking for a use case of automation that is done manually, and cost is indirectly saved. Cost here could directly be saved if you are outsourcing something to a vendor, and that cost immediately gets automated because or reduced because you did it internally. Assuming that somebody else from the organization or your college has given you that project, it also has to be reviewed by the person who has assigned it to you. That checking itself needs to be done in a way where the stakeholder and you are aligned that whatever initial requirements were shared, they are fulfilled and the problem actually gets solved. To a certain extent, that is agreeable within you and the person. So this concludes the process flow for how we estimate a project at the beginning itself. So this was all beginning, but we need to keep in mind that anywhere in this approach we can go back and rework. And at that time we'll need to re-estimate for sure to ensure that once you do that, you can then communicate it to the stakeholders again. Moving forward, there is an example that I wanted to kind of discuss so that we can estimate and see a live example of how to do it. So, this example is specifically of a case study where tweets sentiment classification is done. This project is specifically chosen because most of us, one of the first few projects that we pick up is related to tweet sentiment itself. It's easy to do, it's usually understandable, you are able to make sense of what the data is as well. So in this case, we'll list down all the different phases that we had here in the process flow estimation and try to justify how we have put number of days or number of hours effort that is required. So here we have a phase, specifically requirement gathering. Now, this usually takes 2 days on average for this project. Why? Let's say I would want to understand whoever has given the project or assigned it, what is the purpose of it for them? Why do they want it? What will they do with the result? What will change? So, for example, If I get a COVID, if I take an example of tweets during COVID, a lot of people were tweeting specifically about the actions taken by their own local governments. Now, in those cases, if I am a sponsor of the project or I am somebody who's assigning it, I could come back and say that I want to understand how the public is reacting to the responses that I am taking, that the government is taking in this case. So, in that case, I would want to figure out which government are we talking about, which region do we want to check. Let's say if the Indian government is taking an action, do we also want to check tweets put forward by US nationals or UK nationals? Does it make sense? Or do we want the real perspective from Indians themselves? Or maybe it's not even the real perspective, but fake perspective. So, all of those things, in terms of which tweets you want, who do you want, what do you want to cover, should get covered in this case directly. So that is why it's 2 days. But if, let's say, multiple stakeholders are involved, let's say five people had to come together and give you a requirement, this could definitely change and it could increase a lot. If it's only you who's defining the requirements for your own project, which is the personal project that you're working on today, then it could be less than 1 day as well because you already have a sense or understanding of what is expected or needed here. The next phase here is the literature survey phase. Now, for something like sentiment, it's a widely solved problem today. Now, if you're looking at tweets, let's say from an Indian context, you could come back and say that do we want it in English only or do we also support multiple languages, right? Now, if I put multiple languages in the requirement gathering closure phase, then the literature survey would be vast. But if I put just English, then this becomes a 1 day exercise where it's very easy for us to figure out which are the top models which can be used on English tweets to classify uh, emotion particularly. And you can see find a lot of models not just from papers with code, but also from Hugging Face, which has loads of transformers and models. Apart from that, you can also use popular, let's say, content generation models like ChatGPT, etc. But for something like sentiment, to a certain extent, it's an overkill. Usually, we want the simplest solution to be tried first because it's also one of the most inexpensive solutions, right? So, if you find a solution that works, and when I say works, it means is able to classify tweets with 90% accuracy in English, then it definitely makes sense to use that and try first. It may or may not work depending on whether that model has context of Indian English or not. But again, that's not part of the literature survey, that's for later. So right now we are 3 days of total. Now data availability. If you are somebody whose organization already keeps a track of tweets and keeps storing it, that data fetching could take as less as 1 day. And for you to understand what additional data is being stored along with tweets. It could be metadata like how long has the person been on the platform, what is the age, where does this person live, where does this person work, what's their highest education degree, all of those things could be possible. Now, if let's say that data is not stored, then you need to use Twitter APIs to fetch that data. You need to try and fetch, you need to filter out, you need to search, you need to specifically understand how should you fetch that data in its entirety and how long you should do it for. That itself could take a couple of days, and that is why it could end up being a 3 day exercise on a minimum level, depending on what the rate limit is for the Twitter API or wherever you are fetching the data from. So that is how you kind of figure out and adapt to specific cases where this could change. Coming to data exploration. Now, data exploration is where you need to play with the data and understand what it means. This is where, let's say, in case of tweets, I would want to read the tweets that have come out. Let's say if there are 5,000 to 10,000 tweets, I would want to read some of them and get an understanding of what it means. The second thing that I would want to do here is I would also want to look at what other data do we have and how often is it present for different tweet users. When is it not? When it is? Versus how long have we been getting that data for? All of those things come under data exploration. Drawing visuals to understand what your data is saying is also a part of this exercise. Now, all of this depends on the number of columns that you have along with the domain specific or genericness that is present. So let's say in this case, if I have the tweet and I have 10 other columns that tell me about the user, then definitely it's a process or thing that can be data that can be explored in the next 2 days. And it's definitely doable. If I have 100 columns to check alongside, where most of them have, let's say, more than 70% data, then it becomes very tough for us to do it in 2 days. Then you'll probably need some more days, unless you have a good grip or understanding of what that data is. So that is how this is defined. Right now, if you take it in the worst case, we are at roughly 2, 3, 6, and 8 days, right? But I'll just discount the two because we don't need it. There's data available, we can assume. So it comes out to be around 6 in this case, right? So cool. So coming to data transformation. Now here you need to write a lot of code and functions to kind of be able to generate or transform the data in which you want. That piece specifically covers how what features. So let's say when I say what features in Twitter sentiment, unless you're using a transformer or complex deep learning model, any other model would require you to fetch data. If your data is labeled itself, then what you need is you need to get data, let's say, transformed. When I say transformed, I simply mean you could get how often do the words occur. Is this tweet something that occurs quite often? You could get the TF-IDF score for it. You could get n-grams combinations ready. So n-grams is simply, let's say 1 gram is one word each. So let's say there's a tweet of 5 words. Each word is a token after removing words like is, are, all of those. And if you don't want to remove it, that is also fine. It depends on particular use cases. Now, moving forward, you would want to, let's say, have something like 2 grams where two words together are coming. So let's say if I say Pranav is on a holiday, then Pranav is the first bigram, is on is the second bigram, uh, on a is the third one, and a holiday is the fifth one. So all of those things are broken down in that way, and that is how you can get more and more features. There are lots of ways to get textual features, and you can make unlimited ones. That's how you can move forward there. Now, coming to the first model or baseline, let's say I have labeled data set where I have tweets. Now I've got features and I've got the final label, whether it's positive, negative, or neutral. In this case, I should be able to kind of derive or let's say train a model, and it will not probably take 3 days, but it could take as less as 2 days. But if you're doing it for the first time, I would assume that you would want to pre-process your data to a certain extent. You would want to scale, you would want to one hot encode, you would want to label encode, you would want to remove some features that are not valuable. Because in textual, there are usually, let's say if you have 5,000 rows only of data points, then you cannot have like 7,000 or 10,000 features, which could happen in a textual use case. So do ensure that you have less features than the number of samples that you have. Otherwise, it becomes very tough. So that said, you could train a simple classifier like a decision tree classifier, multi-class decision tree, or a random forest, or a XGBoost. You can do anything. So that model which you build first is your first model or baseline. Usually you divide the set, then move forward with training the model, look at results, and that's your first model. So this can go down or up depending on the complexity of how many data points, what essentially if your negative tweet set is very small, then it could take higher number of days for you to even figure something out for it to work or have a reasonable score. So once you're here, now you want to look at iterations, and let's say you get 70% accuracy, you want to move it to 80, 85. And that is where you need to start planning experiments. So when you think about experiments, you would think about, let's say, I can change these many features, I can add these many features, which is the first thing. The second could be, I can, let's say, for a decision tree classifier, the length, sorry, a random forest classifier, you can say the length of each tree. What will be the length of each tree? The number of trees that are allowed at max. All of those things you can have. And those are what parameters you need to hypertune. So that is, you'll plan, you write down all the experiments that you want to do. Then whichever one, according to, let's say, your own experience or your manager's experience or your guides, project guides experience, or let's say whatever you figure out on the internet, you can rank them according to priority and perform the ones only which you feel will yield a result in those 2 days. And rest of the experiments you can keep for later. So now let's say you move from 70% accuracy to 85% accuracy. That is when you think about deploying this model. And when you think about deployment, or let's say final result sharing, you think about all those things as to how often should I fetch data, when do I want to share results. Let's say you'll have enough tools only in 1 week, so you'll want to share from that time and not before per se. So that is how you could figure out like how much time. So roughly, according to me, if you have a deployment process already that a machine learning engineer can take, then all you need to do is write production ready code, which will only take you 1.5 1 day, along with, let's say, a zero point 0.5 day in sharing those results, in justifying that this is ready for deployment. The last part, once the deployment has happened, usually acceptance testing is dependent on an external stakeholder and it can take as many days as possible. So we don't try to justify or mention that, okay, these many days need to be covered, because we don't have access to that information. Somebody might be busy and it may not be a priority for them today. So this is for the tweet sentiment classification. You roughly get to know that it will take at max around 15 to 20 days, roughly, based on all the assumptions that we took. So be honest about your assumptions, mention them for each phase, and that's how you can have this estimation out. So let's say if I'm starting on October 1st, I can say that, okay, I'll have the first result at least in the first 10 days, or sorry, 13 days. So by October 13th or 14th, I'll have the first set of results. And then you can actually reiterate or come back and say that, no, see, this will take more time because 70 is what I got, or maybe you got 50 as the first result and you need to put in more effort. So you need to figure out that. But the first iteration result can definitely be communicated. So we can say that by 15th, we'll have the first model result. Awesome. So given that we discussed right now the entire process as to how you can define the number of days, we obviously want to understand if there's a standard framework for doing this that's used across companies for managing a data science project. And when I say managing, it's different from estimation. Management happens at end-to-end level. So CRISP DM is actually an industry-based framework that was released in 1999 specifically for data mining processes, but it is used largely in the data science industry today, even for models, algorithms, automations, or any other use case you can come up with. So, given it's a framework, it is adaptable, it is agile in nature. When I say agile, each phase to the next phase can move in any direction. So let's say if you think about it, this is where usually things start, where you need to have a business understanding. You move to data understanding and you can come back to business understanding if data says something else. That exactly is the agile process, agile nature of the algorithm, of the framework. Now there's data understanding, there's data preparation as well, there's modeling of data, there's evaluation, which we discussed, and then there's deployment. Now, this is a completely iterative process in nature. You can never stop the process. Even if you achieve some evaluation result today, you will still want to plan for the future. Now, even though here it's covered till deployment, usually most companies also plan post deployment activities, right? that is not part of the scope of the estimation, because that is usually a ML machine learning engineer's job once you go about it, or a specific data scientist who's experienced with those approaches. But this is how the CRISP DM process looks, and it stands for Cross Industry Standard Process for Data Mining. This is something that you'll find slightly modified to work in most of the organizations. And if you use agile framework with it, that you can go back and look at different ways, or let's say come back after going to a certain stage, then you definitely have a very wonderful framework that works in 90% of the cases. That said, we had kind of estimated and had our own phases that we use in Squad Stack. But let's see now if these phases can particularly fit into the crisp DM framework that we have seen. So I'll just use the same example and I'll add here. So business understanding of crisp DM phase will have your requirement gathering and closure. It will also have your literature survey specifically. Now, literature survey in this case could come under business understanding or data understanding depending on whether you need to understand how the problem has been solved or you are checking what data is needed specifically. Right? That is why it's a mix of business understanding and data understanding as a task. In this case, you need to be wary of the fact that CRISP DM is just a framework. It is not written in stone. And for different organizations, each phase will have different questions to be asked and different tasks to be done. So here, when you come to business understanding in literature survey, this is the same number of days. So we're not changing the number of days. We are only looking at which phase it lies in. Data availability lies in data understanding, right? You can even say that to some extent, if you're fetching data in the data availability phase, it could lie under data preparation, but usually we put it under data understanding itself. Data exploration can come under data understanding because we are trying to understand what the data is, what it means, and how it can be used. Data transformation comes under your data preparation. Now, the most exciting part of building the, let's say, baseline or the algorithm or the first model itself comes under three parts. So there's data preparation, where you split the data into train and test or turn it into a specific format. Then there's modeling, where you create an actual model or try to teach the model what the training data knows. And then you have the evaluation phase, where you have the evaluation metric. So specifically for emotion, let's say if you have a accuracy or precision and recall, you would want to have those metrics measured here. In iterations, you can have modeling and evaluation if you're building on top of the previous model by changing the parameters. Let's say if you're changing the number of trees that can be used in random forest, then it's part of modeling. Now, if you suddenly feel like, oh, the features itself are missing, then in iterations, actually you'll go back to data transformation and you will start again from there. So then data preparation kicks in again. Regardless, the evaluation metrics for the baseline will be compared with all the iterations that we do to understand which is the best model that comes out for us. Now, the deployment phase is where we have the final result, deployment and impact sharing. Deployment, according to CRISP DM phase, is usually how do stakeholders access the results. According to us, it's also making the stakeholders understand how to access, how to use, what is the significance of it, and how often will the results may change or vary, and what you should keep in mind. So all of those things come here. The last part, which is acceptance testing, is usually not covered in the CRISP DM, but it's part of deployment mostly because somebody has to give a acknowledgement or acceptance that this is good to move forward. Now that said, what we have done here is we have understood the entire process of how things flow in terms of how you should estimate at the beginning, how you can definitely give a first model or baseline date that works actually. In addition to that, you have to limit the time spent in each of these phases, which are the phases where you can get lost. Apart from that, there's a standard framework called CRISP-DM, which can be fitted into your different phases or tasks depending on how it works in your organization. Or if you're actually planning your project, then you can think separately about it. That said, I think this brings us to the end of the session where I would let folks get back on questions that we have and maybe discuss those if there are any.
Yeah. So we got one question from Srinivasan. Sir, can
Sure.
you give some sources to get training data for experimental purpose?
Right, sure. So I think in terms of data sources, right, if you look at places like Kaggle, you'll find a lot of data. There are repositories hosted by University of Berkeley as well that has a lot of data. There's other universities in the US which hold a lot of data. Kaggle can also get you a lot of data. Apart from that, if there's specific data sets that you're looking for, you can also find them in the recent research papers that have come. So research papers can be found on, let's say, different journals or different websites that are present, and that will be easily accessible in that case.
Next, one more question here.
Yeah.
Sir, Sujita, she is asking, Sir, can you give some real time project names which are very familiar to society?
Right. I think um, tweet sentiment is one of the most common ones, but if you look at other, there's image recognition via on handwritten digits, which is very common. There's the Titanic data set, which is a survivor data set where people use. Apart from that, there's also the defaulter bank loan data set, which specifically is a problem where you identify who you should give a loan to versus not. If you talk about real world applications as to where it's most commonly being used, today AI is being leveraged across platforms. So let's say I'll give one of the examples which I love. So these days, papers are being read by AI voices, and you can listen to those papers. Music is being created by AI. Books are being read automatically, or books are even being written, by the way, these days. But some classic examples are always customer segmentation, where you figure out which customers should I sell to, or which customer should I market to. Any marketing firm or any sales firm would need that. Additionally, even people in banks are very, let's say you have things like credit score. Along with credit score, they look at multiple factors before thinking about whether a loan should be given to you or not. Right. So all of those are part of either statistical analysis, data science itself, or actually deep learning models.
And some good compliments. Prahalad, he is saying very informative session, sir.
Thank you
And
so much.
one more question here.
Yeah.
Namrata, Namrata, she is asking how to determine which algorithm will give better results for doing sentiment analysis.
Right. I think that's a wonderful question. So, going back to what we discussed, so let's say if you look at, if you perform literature survey in the right way, you would get various examples of understanding which models gave the best results for sentiment, particularly on the kind of data set you want. So, let's say if I fetch tweets and I want, it's an open data set. So somebody would have written papers comparing various approaches as well, or somebody might have written an article. If this is to start with, if your organization does not have experience, if somebody in your organization already has the experience, they can definitely help you with the kind of models that have worked very well. So in our organization, we deal with calls data. So we are looking for emotion models specifically for calls. We figured out some transformers on Hugging Face, that do a okay job. When I say okay, because state of the art is 75 on American speaking calls, in on Indian speaking calls, the accuracy is very low. It's around 50-55 right now percent. So that is how you understand and compare. The second way of comparing is you pick some of these easy models. If you have a data set of your own, run those models, and if that data set is labeled already, when I say labeled, it should have the ground truth. You should have whether the tweet is positive, negative, or neutral, and that you can compare across models. So let's say if you found five models and you have a data set, you run that data set on five models and see which models give you the best result, right? So there are both approaches that work very well. It's like I said, it's a science for sure, and that is why it's so different than other fields or how, and that is why there's always a question of how should we move forward. So I hope that answers the question.
Next question, Vinay Kumar.
Yes.
Can you suggest a data set for implementing recommendation systems?
Right. So I think the most famous one that we have is movie lens dataset. There's a data set also by Netflix. So unsure if many of you know that the Netflix movie recommendation engine that worked for a lot of years was something that was built basis on a Kaggle competition itself. So there's a lot of movie recommendation data out there. Now, if you want recommendation data sets for books or something else, you can morph the features from the movie data set itself and build a new data set. But mostly things like movie recommendations, book recommendations, or song recommendations, specifically for given that we are in an age of Spotify's or Ghana.com, everything. So those can be found online for sure. Movie data set is available for sure. I have seen music recommendations as well.
Bandi Vaishalini, she's saying excellent session, sir. Sayyada Farhana, very informative session. Sharanya Rani, nice session, sir.
Thank you.
Mallikarjuna, nice session with good examples, sir. Anusha, nice session. Ashok Kumar, he is asking best deep learning model for image classifications.
Right. Uh, Good question. I think, see, the answer is not so simple. The answer usually is it depends on the kind of data set you are using. It depends on, so I'll give you a similar example. So let's say ChatGPT or let's say Bard are the most looked after LLMs today. But lot of people, they are generic LLMs in nature. If you're looking to solve specific tasks, like let's say just question answering, then you may want to focus on using specifically focused LLMs instead of these ones. And Llama or even smaller LLMs might work better. So it's the same thing. It depends on the kind of data set or the problem you're trying to solve. If it's image identification, then it's very easy. Depending on image classification, depending on if you want to classify it into animal, car, vehicle, some other category, right? But if you want to do specific things like this is an original red Reebok shoe versus this is not, then that requires specific kind of data, right? So to even train the model, and models will be different in that case. Yes, but Hugging Face is a and TensorFlow Hub are two very good sources to find few of the best models to start with.
So VJ is asking, can you suggest some open sources to learn DS?
Right. So I think one of the best sources is Coursera. So Coursera is actually not paid if you just audit the course. Secondly, if you are a student, they'll give you discounts as well if you write to them. The second few ones are there's always a lot of things on YouTube, but I think a few article related things are medium towards data science. There's Data Science Central, there's KDD Nuggets, along with other sources. If you're looking for books, Python for data science is a good start. While if you're looking for specific into mathematics, then Andrew Ng's machine learning Stanford's course is the best to start with. It's very in depth. The person is a renowned leader in the field of data science, and he has also initiated a lot of deep learning courses. So even on Coursera, you can use the free courses by auditing them. It's always a choice. So you'll get lots of free resources for it. And apart from that, I think Unacademy will not have, but Data Camp will definitely have a few exercises if you want to check.
I will take one last question.
Sure.
Yes, Dastagiri, he is asking, DS is a part in AI? Question mark.
Right. So it's definitely, so let's say it's AI itself, artificial intelligence means that there's some way, some system that is able to understand or let's say do something by itself, and it keeps on becoming better, right? Machine learning models or data science is essentially a problem solving way. Now, when you solve it and you actually create a way in which the model keeps getting updated, it becomes an artificial intelligence system, right? And there are various definitions of breaking it down, but usually all these are interlinked. And regardless of whether you are working as a data analyst or a data scientist, or let's say artificial intelligence expert or a machine learning engineer, it depends from organization to organization as to what your work would be. So, so ideally, you should definitely have an understanding of what each of them means, but look at them from a high level and not specifics. Because if you look at specifics, you'll find a lot of overlap in them. Yep.
Right, right. So, and most of the people they are saying very informative session, excellent session, nice session. Thank you, sir.
Awesome.
So I will
Happy
stop
to add
taking
that.
the queries here due to time factor. So
Sure.
now I feel it privilege to thank each and everyone for attending this day 3 session of 1 week international level faculty development program on introduction to artificial intelligence during 9th to 14th October 2023, organized by the Department of Electrical and Electronics Engineering in association with NI Lab Academy of GPREC and Department of Emerging Technologies in Computer Science with the Department of ECE. First of all, I would like to thank our today's resource person, Pranav Bhargav, Decision Science Manager, Squat Stack. So, for
Thank
dedicating,
you so much. It
dedicating
was
his
great.
valuable time with us. Thank you very much, sir.
Thank you.
And also, I thank our Honorable Chairman, Sri P. Subbareddy Garu, for supporting financially. Thank you, sir. So, I thank our Principal, Dr. B. Srinivas Reddy Garu, for providing logistics. Thank you, sir. I thank Head of the Department, Dr. K. Siri Gori Madam, for her continuous support. I also thank Head of the ECS Department, Dr. R. Praveen Sam Garu, for his continuous support. I also thank Head of the ECE Department, Dr. S. Nagaraj Rao, sir, for his continuous support. Thank you, sir. Finally, I also thank all the HODs, professors, in charges, and various cells of our college faculty members. Thank you very much. So, here is the end of today's session. Once again, I thank today's speaker for providing very informative and useful sessions to our participants. Thank you. Thank you very much. Here is the end of session.